Hey y'all, in today's video we're going to get into a little bit of a discussion on how to reduce machining times when it comes to 3D carving. What I have up here is a wedding sign based on a design given to me by a friend of mine who his niece just recently got married and he wanted me to cut a sign for him. The names were changed to protect the innocent, and of course, the sentiment was changed just because of my sense of humor. Now, what we have here is I have just a 3D roughing, 3D finishing toolpath that's going to carve this entire center section out here and leave these two banners and the two wedding rings, and a 3D finishing that will complete the carving. 60-degree carving up here in this banner and this banner. Some 90-degree carving down here. An outside bevel along this edge, along this vector here, to give the outside of the piece a nice bevel. And then the profile cutout. And as you can see by my Toolpath Summary here, this is a 10-minute and 47-second carve. That is due to a couple of things, but mainly just by the sheer size of this project. The cutout size, the finished size of this project is going to be 12 inches wide, 18 inches high. So it's a large plaque. And as we can see, we've got about a 1-hour roughing toolpath time to rough out everything within this vector here, and a 9.5-hour 3D finishing toolpath to finish everything within this vector here. Now, why did I select this strategy? This is going to give the absolute best finish. There are no tool changes involved. Any machining marks left in the roughing will be removed by the finishing toolpath. And because it's all done at once with the same bit, I'm guaranteed the most consistent finish throughout this entire vector boundary of any of the other strategies. The penalty I'm going to pay for that is in time. So, just throwing it out here right now, on a project like this, if time is not really a concern and you're more interested in not having to get in here and do a bunch of sanding because of machining marks that were left behind after the tool change, then this may be the strategy. I, on the other hand, have to be concerned with time. So I took the exact same design and I made a couple of changes. And that brought me to this strategy, which reduced me down to 6 hours, a little over 6.5 hours. It cut my roughing time down to 16 minutes from over an hour and knocked about almost 4 hours off of the finishing time. It's still going to give me the same result. However, I may have a little bit of sanding to do around this transition area here, where I transition from a 3D roughing and finishing toolpath to a standard pocket toolpath. Let me show you what I'm talking about by bringing up a third window here. I took out all the pockets and everything to show you how I created them. That's what I'm going to do right now. I'm going to show you how I created the vectors surrounding this 3D carving to reduce the machine time, and a few other changes I made to the tool pathing strategy, which saved me about 4 hours when it comes to machining this plaque. So we'll start by switching back over here to my drawing tab. And what I want to do is I want to create a vector that'll surround this entire area right here. And the way I'll do that is I'll go ahead and select this banner, hold down Shift, select this banner. I'll go down into my modeling tab, then I'll come up here to under modeling tools to this icon right here, create a vector boundary around the selected components. And that's going to create that vector around each of these ribbons. Now, if I zoom in here and just select the bottom one, we see that both of these, they are grouped. So the first thing I'm going to need to do is ungroup these objects back onto their original object layers. We'll click on that, and we see it goes from a solid pink line to the dotted pink line. Now I can come in here and select just separate vectors. Now right off the bat, I do not need these inside vectors here, so I can select, tap delete on my keyboard. I don't need them. They'll just confuse matters. Same up here. I don't need this one, and I don't need this one. Now we're going to get into a little bit of node editing. I'm going to start down here by selecting this vector, zoom in over here on the side, and I'm going to tap the letter N on my keyboard to go into node editing. I'm going to come over here to this point right here because it's the furthest one to the left in this vector, and I'm going to right click. I'm going to cut the vector. Now we see here the keyboard shortcut is C. I'm going to remember that. We see this point turned into a start point. Then I'm going to come over to the other side, and I'm going to do the same thing. I'm going to pick the point that is the furthest to the right. Put my cursor over that, tap the letter C on my keyboard, and that cut the vector. Now we have two separate open vectors here, and the one I need to get rid of is this one right here. So I'll just select it, still in node editing mode, and I'll tap delete on my keyboard. So I'm left with this vector down here. I'll go back up to the top and I'll do the exact same thing. I want to select this vector, come out here to the vector that is the furthest out to the right, and I'll cut vector. I'm going to put my cursor over this point, tap the letter C. Sometimes you've got to zoom in because it doesn't know if you're hovering over the point or one of the handles. So I'll zoom in, tap the letter C, and we've cut the vector. So now I have this vector selected. I need to get rid of this one. I'll click on it, delete. So now I can tap the letter N again to come out of node editing. And I have the first step to the vectors I want. I'll come in to my drawing tab, come up here to draw a line or polyline, and I'm going to zoom in and come up here to the end of this vector and click. Then I'll zoom out and come down here to this vector to where they'll join up. It snaps to that vector because I have smart snapping turned on, and I'll click. Bring it out here, away, hit my space bar to finish that line. Then I'll do the same over here. Okay, that's the preliminary vector. Now I want to take this vector here and grab all of the different segments, and I need to join them into one closed vector. So I'll come over here under Edit Objects to Join. I currently have 4 open vectors. I'll go to one closed vector. Now I can close that, and I have my closed vector. Now I need to offset this outwards. I want to get away from the model because I'm going to be pocketing up close to it. So I will come over here to Offset. I want to offset outwards 1/8 of an inch. I'm then going to click on Select New. That way, when I hit Offset, the new vector will be selected. I'll click on Offset. Then immediately, I'm going to click on Offset again. Close that. Now I can come back in here and the original vector I created, I'll delete that. I now have my vector boundary for my pocket and my vector boundary for my 3D roughing and 3D carving. The reason I chose the outside vector as my boundary for the 3D carving and the inside vector for the pocket out here is because I want that little bit of an overlap. I'm going to run the pocket toolpath first out here, but in the 3D carve, I want it to come out and overlap slightly, just to make sure I didn't leave anything unmachined here. Now, we can do a little bit more refining of the design if you choose. You can come in with the fillet tool, for example, and fillet this corner here and then this corner there if you choose. Strictly speaking, it's not necessary. It may or may not save you any time, but that's 100% optional. It's up to you. It's not required. The only thing we need to make sure is that these are closed vectors, and then we'll want to reduce the number of points we have in them. Because right now, if I tap Node Editing, you can see how many points we have down here. So I'll fix that by selecting that vector, come over here under Edit Objects, to Fit Curves to Selected Vectors. Click on that, and I want to make sure that I have Keep Sharp Corners selected and Replace Selected Vectors selected. If I don't have this check mark, it's going to create another vector over the top of this one, and I'll have a mess on my hands trying to delete one of them. So, Replace Selected Vectors is selected. This is the number of points we currently have. I'm going to change over to Bezier curves and click Preview. And we see how many points that's reduced this to. So much nicer. I'll click OK. I'll then select this vector and do the same thing. We've got a huge number of points here. I'll select Bezier curves. Make sure I've got my check marks here. Preview. Select OK. Now, if I were to go into Node Editing, that design is a lot simpler. Come out of Node Editing, and now I'm ready to go calculate these additional toolpaths. So, I already have these set up. I'm going to kind of start over a little bit. I'll have to go in and recalculate these, but you'll see as we go. The first toolpath I want to calculate will be my 3D roughing and 3D finishing toolpath, mainly because I don't know how deep I need to make this pocket until I figure out the max depth that's going to be carved up here. So I'll start by selecting all three of my 3D models and my outside vector here. Do a 3D roughing toolpath, and I'm going to use a 1/4" end mill. Here's another tip as far as machining times are concerned. I'm using a 1/4" end mill. I have my feed rate currently set at 60 inches per minute. I start conservative, and then as it's cutting out on the machine, I can increase the feed rate just based upon how it's cutting. I can bump up the feed rate until I start to get a little bit of chatter, then back it down. But I start conservative. You'll notice I also have my plunge rate set at just a little more than half of my feed rate. 3D carving takes time because the Z-axis is almost always in motion. Not always. There are some flat areas here, but it's almost always in motion. And the controller software is going to carve at the slowest axis feed rate. The slowest axis feed rate in this case is the Z with the plunge rate. So I can put anything I want up here in my feed rate. In the areas where the Z-axis is in motion, it is not going to go any faster than this plunge rate. I set my plunge rate at a little over half of my feed rate. That's going to vary based on your machine. Some machines can handle a plunge rate equal to the feed rate, and that's fine. Others can't. This is where you'll need to do some experimenting on your own. Start out at half of your feed rate, and then as you do more and more projects, you can bump it up until you get to that point where you think maybe you're going a little bit overboard. So I wouldn't go any faster than my feed rate. I would make sure that these were equal or the plunge rate was less than the feed rate. But that's going to take some experimentation on your part. Okay, I'll cancel that because I'm not making any changes. I'm going to use a boundary offset on this toolpath, on the roughing toolpath, or negative 1/8 of an inch, meaning the roughing toolpath is going to carve 1/8 of an inch inside this vector. It's not going to go completely out here. It's going to leave that material for the finishing toolpath. I'm using a machine allowance of 30 thousandths, meaning this bit is going to carve down to the level it needs to go to, leaving 30 thousandths, a skin of 30 thousandths of an inch for the 3D finishing toolpath to remove. My roughing strategy. I'm using Z-level. The Z-level strategy, the bit will come down to where it's 30 thousandths above the model and start clearing away there. The other option is to do a 3D raster. 3D raster, the bit will come along and follow the contours of the model, leaving that 30 thousandths of an inch allowance. The problem with that is you're almost going to double your machine time because that puts the bit into motion following these contours running at the plunge rate. Z-level is much quicker. If you're using a tapered ball nose bit, it can handle the amount of the material that's left behind by the roughing toolpath. This is a quicker way of hogging out a bulk of the material without taking a lot of time. If you'd like to try the 3D raster method, be my guest, but do know it's going to take, at the minimum, double the amount of time that the Z-level strategy will take. I'll go ahead and calculate that toolpath. And we see right now, I'll preview it. And we see right here that it cut down about 1/8 of an inch into the material. It did not get down in here where the ribbon actually is, and it didn't try to carve away any of the rings. It left the material that is going to make up these sections of the rings to be carved by the 3D finishing toolpath. So I want to move that up to the top, so I'll click on these arrows, and there we go. I'll close my preview window. We'll go back over to my 2D view, and with those same vectors selected, I want to do a 3D finishing toolpath. 3D finishing toolpath, I've got my bit selected, a 1/16 inch tapered ball nose. I'm going to machine to the selected vector, again the outside vector. I'm going to machine this in a raster strategy. I want that bit to go back and forth. I don't want it to go in circles. And I'm going to calculate that toolpath. This will take a while, so we'll let it do its thing. Okay, with that toolpath calculated, I can go ahead and preview that. I can see it better with this material rocked back a little bit. Hopefully you can too. Now if we look here, our 3D finishing toolpath, and we look down to the second line from the bottom of that little window that pops open, we see that our max depth is 0.27 inches. That's how deep that's going to cut out here, 0.27 inches. That's the depth I want to cut my pocket. So let me go ahead and bump this up above my 60 degree and 90 degree toolpaths. And again, these will have to be recalculated. I'll close my preview window, come back over here into my 2D view, and now I want to cut my pocket. So I'll select the outside vector, and holding down Shift, I'm going to select the inside vector here, because again, I want that overlap. I'll go up here to my pocket toolpath, and as I've already done this a couple of times, my cut depth is already selected. I want it to cut down to the same level as this area in here was machined out during the 3D finishing toolpath. That's 0.27 inches. I'm going to use an 1/8 inch end mill to give me a tighter radius up here in these corners. And I'm going to use a 1/4 inch end mill as my large area clearance tool. It's going to do both of those in 3 passes. That's fine. I'm going to clear the pocket using the raster method because, again, I don't want any of the machining marks left behind by the offset method. I'm going to ramp my plunge moves with a 1/4 inch end mill. I'm going to go ahead and go over a distance of 1 inch, and we'll calculate. And this gave us 2 new tool paths: the pocket clearance tool that uses the 1/4 inch end mill, and the pocket finish, which uses the 1/8 inch end mill. So I'll uncheck that, and we'll preview the pocket clearance first by selecting that. We'll preview that selected tool path, and we see that that's going to go through and carve out the rest of that area not previously carved by the 3D roughing and finishing. Now we'll do the finish pocket toolpath. And basically all that did was carve around the perimeter out here. Okay, we're on the right track. We're looking good. And so far we have a much reduced machining time. Let's go ahead and close that. Now I need to calculate my 60 degree VCarve. This is the text I want to VCarve on that banner. You'll notice up here I have no start depth selected. I have no flat depth selected. The reason is because I have a check mark down here to project the toolpath onto the 3D model. This projects all of this V-carving down onto the banner. The software knows where to start that carve. So I don't have to do any math. I don't have to figure anything. All I have to do is make sure I have the correct bit selected, and I can calculate. Then we'll preview that toolpath. I selected black as my machine color so you can see. There we go. We'll come back into the 2D view, double click on the 90-degree VCarve. We have our text selected. Now, because I do not have a 3D model down here, I need to set a start depth so that the bit will start carving on this surface that was already pocketed out. My start depth will be 0.27, the same depth as we pocketed. I've got my tool selected. I'm not using a flat depth. I'm not using a flat area clearance tool. And I'll calculate. There we go. Again, my toolpath color is black. I'll preview the toolpath. And there we go. I'll go ahead and preview the outside bevel because I already know that that is correct. Basically, I selected this outer vector. I want it to cut 1/4 of an inch deep. I'm using the same 90-degree V-bit, machining on the vector. That is the only other information I need. I didn't need to recalculate it, but I did it anyway. Now I'll preview that toolpath, and that cut that deep V-groove there. Now I can go over to my profile cutout. I set it to cut through the material on the outside of the vectors, a separate last pass with an allowance of 0.01. I put tabs, 3D tabs, 1/2 inch long. Let's go 1/4 inch tall. I'm ramping in my plunge moves, a smooth ramp over a distance of 2 inches. And I've made sure I've got sharp external corners selected. Calculate, since I did make a change. I know it will cut through. And we'll preview that toolpath. And there we go. There's our finished sign. Now let's come out of the preview, select all of the toolpaths, and see what we got. And we have just under 7 hours. Going in to tweak this a little bit, I could speed up some feed rates and plunge rates. I may still do that. Let's close this and take a look at our pocket toolpath. What do we have for a feed and plunge here? 60 and 30. This is not going to do much as far as cutting down on times, but it's worth a shot. These are not going to take, they're only going to take about 3 minutes apiece. There's not much savings left to be had by playing with any more feed rates. I can save more time by speeding up the feed rate on the fly outside on the machine. Those are the basic methods I would use to reduce machining time on a 3D model cut. And that is to reduce the amount of material you're carving away. Optimize your feed and plunge rates as well. And that will help you reduce your machining time on 3D models. Still, the main thing to remember is that 3D models just take time. Let's take a look at here and you'll see why. If I come over here into my 16th inch tapered ball nose, I'm running a step over of 9%. That's going to give me good detail without a lot of finish sanding after the fact, but that means it's only stepping over a little more than 5.5 thousandths every time it makes a pass. So when we talk about getting a lot of detail without a lot of cleanup work, it's only stepping over 5.5 thousandths. So you can imagine the number of passes it's going to need to take to get this finished. I mean, I didn't look at how big this is, but we're machining to that area. I can come over here. We're basically looking at a, you might as well say 10 by 11 area that's being machined out. 10 inches by 11 inches. 5.5 thousandths per pass. That's why 3D model carving takes so long. So there are little tweaks you can do to optimize your tool pathing. There are little things that you can do to help reduce the amount of time it's going to take. But basically, what it takes is rethinking your strategy in just how much of the total area you actually need to 3D carve, and how much of it can be done using another strategy, like pocketing. I hope you got something out of this video. If you did, I do hope you'll give me a thumbs up. Don't forget, today at noon Pacific, 3 p.m. Eastern, I'll be doing a live Q&A on this subject, on anything I've covered in this video, or any other suggestions or questions about reducing machining times for 3D models. So I do hope you'll join me. If you're not subscribed to my channel, now would be a good time to do so. And click that little bell button next to the subscribe button. Then you'll get a notification when I schedule a live video and when I go live. Again, I hope you got something out of this video. I hope to see you this afternoon for the live Q&A session. And as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch, and y'all take care.